Good afternoon. Welcome to PCI's webinar series. Today's presentation is how BIM intelligence can reduce time and cost for your precast girder bridge projects. This webinar is sponsored by Allplan. My name is Royce Covington, Manager of Member Services at PCI, and I'll be your moderator for this session. Before I turn the controls over to your presenters for today, I have a few introductory items to note. All attendee lines are muted. The GoToWebinar toolbox has an area for you to raise your hand. If you raise your hand, you will receive a private chat message from me. If you have a question regarding the material, please type it into the questions pane, where I'll be keeping track of them to read to the presenters during the Q&A period. Also, a pop-up survey will appear after the webinar ends. If you experience any difficulties, please email PCI Marketing at marketing@pci.org as shown on your screen. Today's presentation will be recorded and uploaded to the PCI e-learning center. Questions related to specific products or publications will be addressed at the end of the presentation. PCI is a registered provider of AIA CES, but today's presentation does not contain content that has been endorsed by AIA. Today's presentation is non-CEU. Our presenters for today are David Lockery, Business Development Manager of Infrastructure at Allplan. David has a master's in structural engineering with over 7 years of industry experience. As a practicing engineer in China, his work focused on fiber composites, FRP, and civil infrastructure, including bridges and power plants, before he transitioned into the AEC software industry upon returning to the United States. As an engineer, he's faced many of the same challenges which confront Allplan's customers each day, an understanding which enhances his ability to help overcome them. Joining David is Anders Lovendahl, technical consultant at Allplan. Anders studied at Oregon State University before starting his career at a precast manufacturing facility specializing in pre-stressed precast concrete bridges and drafting. He also has experience as a CAD manager, supporting civil and structural engineering teams throughout all phases of project delivery. He enjoys keeping up with emerging technology that can create innovative workflow solutions for infrastructure projects, which was a driving factor for joining the Allplan team as a technical consultant. I'll now hand the controls over so that we can begin our presentation.
Thank you for that introduction. Today we're going to be presenting a workflow for using our BIM engine and the automation that's built into it to detail and ticket precast girders for bridges. This is a market that has not received a lot of attention from the folks who build detailing solutions like ours historically, and we think we have something quite impressive to show everyone today. Before I turn this over to Anders, I am going to very quickly go through why we did this and what we think it offers. So when we look at the way that we do this now, and Anders did this for many years, we rely heavily on the automation tools that are built into CAD. As detailing practices that are feeding directly into precast, we're not getting paid by the hour. We're an overhead cost here. So the quicker and more inexpensively that we can do things and the more mass producible they are, the better. But in CAD, there's a huge trade-off between using things like templates and standard details and even recycling past projects versus maintaining the accuracy and precision that we need for our tickets and for our BOM. When I do this, when I take an old set of tickets from perhaps a project that uses the same girder section, has a similar span length, I have to take great precautions to ensure that my drawings are scrubbed properly, that none of the old line work, none of the old dimensioning and annotation is bleeding into this new project. And it culminates in a process where, despite having drawn all these things on a computer, I'm then basically counting them manually. What we would like to propose is a workflow that's going to rely on everyone's existing CAD skills, is very friendly to the folks who have been in this industry and doing this work for a long time, but which offers much less of a trade-off between speed, drawing quality, error reduction. And the way that we do that is because we have these BIM tools, because of their intelligence, because of the automation we offer. Frankly, we can use better templates. Our software understands what bar is. It understands the concept of clear cover, bending pin factors. And what we do with this is build a set of drawings, functionally identical in every way to what you're culminating in today, but using a workflow that's significantly more automated and that does a lot more of the checking and the error reduction for you. And it also, at the end of the day, delivers completely accurate bills of materials, bar bending lists, and fabrication data, all from one location. With that, I'm going to turn it over to Anders, who's actually going to show us what's going on. And Anders has queued up an example of one of the bridges that our software can be used to model. Today, we're going to take something that is a little bit smaller, more straightforward, and detail it out end to end to show everyone exactly how the automation and the intelligence in Allplan will aid them in detailing and ticketing their girders. Anders?
Yeah, as David said, we're going to focus more on doing the precast girders. So I just hid the deck and the railing that was on this bridge to expose the girders underneath. So we'll go ahead and I'll show kind of the workflow of detailing these and putting one together in Allplan.
And we're going to see right off the bat that I know models like this look intimidating. We're going to see right off the bat that what Anders is doing is going to be very friendly to folks who have spent their whole lives working in CAD, who have a complete set of skills developed in CAD. The goal here is to bring all the advantages of 3D to people who are used to working in 2D, so that we can get that intelligence, that automation, using basically a CAD work set.
Yeah. So I picked a more friendly looking bridge, only three girders, should be a pretty easy framing plan to replicate. I'll jump into a blank drawing file to start this. This one looks good. So modeling girders is pretty simple. It's basically an extrusion of a 2D profile. So I can go ahead and load in the one that I have. I'm from the Pacific Northwest where deck bolt tees are really common. So I'm going to use my typical section that I have, the deck bolt tee, and extrude that. So I'm just pulling it from my library, placing it out in space. You can see it out here.
And these libraries work exactly the same way they would CAD. In fact, they can be extended a bit beyond CAD. We have customers who are doing precast work, who are doing engineering work, and they can save whole completed projects like a completed girder, and use that as the basis to start another one from. And I know that happens a lot today when you have when you have a CAD workflow. The first thing you do is you go back and find the last project that used this section, see what you did there, steal as much of it as you can. But a lot of times we got to scrub a ton of stuff before we are able to move forward. Here we can make that a lot easier on folks.
Yeah, much easier. Now once that I have my 3D object, my shape of my girder, we need to convert it over to a precast element. So in our precast element tool, I can choose what the element type is. For this, it's a girder. You can always add more in our catalog. You can also include more model information, things like attributes. I've added a couple where I could add in the estimated camber for a girder, the shrinkage or the shortening of pre-stressing in here. Just as an example, I'm not going to type in anything, but for this tool, I just have to select my 3D object and it turns it into a precast element.
And that'll come into play later on. What we do when we say we're turning something into a precast element is we're embedding it with some of the data that the software can leverage later on to do things like manage multiple versions of it, understand which elements, which precast components are identical in a project, organize mark numbers, things like that. And then setting up the actual kind of area in which we're going to work is exceedingly simple. We plunk down, we plunk down a couple of views of this thing that we've created. We have, as you can see, Anders has a plan and an elevation view up. We're going to cut a section out of it so that we can do the detailing in that section view. Nothing complicated about it.
Yeah.
But what it does is it allows us to work in 2D.
Yeah, so now that I have one girder modeled and turned it into a precast element, the program automatically marks the piece for us. It tells us the height and the length of the piece, the estimated weight of it. And now if I want to create the other two girders, I can just simply select the one girder. Select the one girder and copy it. And now if we look at this marking again, it's already marked the next piece and gave it the next number, so a 5. You can start the numbering from any number. I think I added some pieces before this, and that's why that we're starting at 4 instead of 1. So don't be too concerned with that. We can change it if we wanted to. So I'll just make another copy.
And we can also set the mark numbers to mark identical pieces with the same mark number. We can manually override mark numbers. Basically, the full range of every way that you might want to organize these things is achievable.
Right, right. So now if I want to add things like, let's say, a concrete insert, or in this case, I'm going to add like a flange weldment connector, we can do that just by going up and adding a fixture. Fixtures can be plates, inserts, you name it. It can be a fixture.
And again, like everything else, we've got a full range of libraries here. Our parts library already incorporates most of the standard hardware sold by the big manufacturers, the Meadowberg, the Dayton Superior, sorry, rather the Halfin folks, the Dayton Superior, the Shore-Builts. But we also can custom create these elements very quickly, either create a standard 2D cell, create little 3D objects. The whole point is, once you've done these things once you've used them once, they're there forever after, and you can use them, reuse them instantly and endlessly, just like in CAD. Cool thing is, unlike in CAD, once I've put all of these in, I can report out on their exact numbers. I can replace subsets of them with a different element. I can replace them all with a different element, all at the push of a button. A lot of intelligence that is useful to me. That's not available when I'm doing these things and they're just 2D line work on digital paper. And again, like CAD, full kind of range of functions that I might want to use. I've got my copy functions, I've got my mirrors, I've got my arrays, which means that once I've put something down, I can very quickly populate the whole project out with that object.
All right. Now that I've added those weldments, I kept on typing in the wrong dimension, so I apologize for that. I can now create a detailed drawing of each of these girders. So basically what we're looking at right now is the final condition of the girders. So what's going to be erected and be on site. And with the detailed drawing, we can actually create a linked version of this girder, one that we're going to actually be using for the shop drawings and for fabrication. And so we'll be able to add some additional length to the girder for shortening, to account for things like shortening and the pre-stressing forces. So now we've created our detailed drawings of those girders. I can hop over into one. Now we can just focus on one girder at a time if we want. And when we add reinforcement and additional items to it, we can also copy those items to the other girders as well. But for now, I will stretch the girder to add some length for shortening.
And again, keep in mind what we just did by creating this detailed drawing file is make it so that when I do this, this is still one object, and the software still understands that this is the same girder that's going to appear on the framing plan with different dimensions. When I add things here, or I add things into the ticket, or I add things into the model, it's going to appear across all the sets of associated drawings, even with that dimensional alteration. It's actually really cool. It's incredibly useful for eliminating a lot of the sources of error that exist in this process as it has been done for the last 20 or 30 years.
Yeah, traditionally,
at the end of the day, error is money.
Yep. And traditionally, I mean, just from my own personal experience from working on a precaster, most of the time when we detailed girders, it was just simple 2D line work, and the girders weren't connected. The framing plan girders were disassociated with the line work and what was making up the shop ticket version of the girders. So this is one way to really solve that issue of having two different truths. Now we just have one single source of truth. But I was going to show that originally the framing plan girder that I made was 115 feet long. I just quickly stretched this one to be 115 feet and 2 inches, 2 inches for shortening. So you can see that here. And you saw how simple it was to stretch. But now we can add some reinforcement. And to do that, I'm going to first create a section cut of the girder. Just going to do this right at the end. Looking down station, and there we go. Now we have a section, and then I'm just going to add a few bars that we can use as an example of reinforcing this girder.
And like everything else, this is going to look like CAD. It's going to feel like CAD. The big advantage is it's going to be smarter than CAD. So here, when I place bar, I can drag, click, drag, drop all of this line work exactly like I would in CAD. But for example, you can see we've got bending pin factors that are automatically pegged to the bar size that we've chosen. We have clear cover requirements, both laterally and on the ends, that we can adjust. We can change those bending pin factors. And more importantly, once we get around to populating this and adding it all in, we'll see exactly how quickly and easily we can query it for quantities information, BOM data, and how quickly that can be modified when something changes. Really the heart of what we're doing here is it's not a 3D model for its own sake. Girders aren't complicated enough in most instances. They aren't congested enough in most instances to say we should just build a 3D model of everything to make sure it fits. These are 3D models that we're using in concrete ways to create information that changes the way we do business down the line and makes things cheaper for us, allows us to avoid costly errors, allows us to make orders earlier, lets us keep that little pile of bar ends that's somewhere in the corner of every shop floor from accumulating. It's not much, but it's a few $1,000s every year. Avoiding errors is a lot more potentially.
Yeah, so now I can quickly pull up a list of reinforcement. I haven't actually placed the bars into our girder. I've just created the shapes of them, but they'll still show up in our list of reinforcement. It just shows up as 0 pieces because, like I said, we haven't actually put them into our girder. But I want to show that once we do add them into our girder, that the number of pieces will increase. So right now they're showing up as 0 because they're not actually in the girder yet, but they will here in a moment after I use the sweep bars along path tool. So now that we've created the bars in our element, there's a few different placements of each bar for the different spacing, and our quantities have increased. We can, since all these bars are the same, we can quickly use one of our rearrangement tools that looks for similar bars, identical bars, and combines them all in our list, making it cleaner.
And we know we only have 3 bar types in here, so this checks out just right off the bat. The cool thing here is, one of the cool things here is, and Andres is pulling this out right now, is a detailed schema for fabrication purposes. So we can always pull out these little visual depictions that can be used to bend bar by hand if there are only a couple of a bar. In addition to that, we can export files that contain this data straight to bar bending machinery, things like BCBS. We can also export ASA and SULE, the 2 main file formats for bar fabrication management, whether you're doing that in-house or whether you're doing it with a detailer. When you can deliver these files right off the bat, it's something that you're not paying to have created within those platforms. It's something where you're not having someone manually type in a bunch of information about bar legs and angles and bending pin factors. Again, it's error reduction. It's not creating the same information twice. And as you see here, when we make changes to these bars, everything changes alongside them. So if I delete a bunch of these bars, the changes that I've done are going to reflect over to this list live. I've reduced the number of bars and everything, and I can just as easily undo it when that was a mistake. The way that this concept gets called a lot of times is a sole source of truth. And it really is the biggest downfall of doing these things in CAD, is that I need to make sure that everything is consistent across all of the information that I present, that my tickets are identical to my my framing plan, that the bill of materials accurately reflects the number of pieces of rebar on the ticket. And that takes a lot of effort. This doesn't.
Right. Well, that brings us to the next point of just creating a shop drawing super easily.
So the magic button, in other words.
The magic button. Yes, that's right. So if I just use our element plan and just select our precast element, I can pick from a variety of layouts that I have for girders, which I only have 2, but you can specify that in our catalogs. And if I hit OK here, we have a shop ticket. So if you blinked, you missed it. Pretty quick, simple. We've already generated a plan view, elevation view, 3 different sections along the elevation view. You can see our reinforcement and our weldment connectors. We've already have overall dimensions, spacing for the shear connectors. We can zoom into the top left here. We have a list of fixtures, so 22 weldments on this girder. If I go to the next page, we have more of a end reinforcement detail page, and our list of reinforcement shows up here again.
And having done it once, then now I can copy as much of this as is relevant across to my other girders. I mean, in this case, of course, all 3. But in the case of those huge projects where you have 40 spans of viaduct, 10 girder lines, and maybe 55 girders are identical on a project and another 35 are almost the same thing, but not quite. This makes the job of managing all that information a heck of a lot easier.
Yep, and everything in these drawings is live. So what if I make any changes to the girder here, it's reflected in the model. It's connected to the model. If I move this, let's just say, for example, I move this plate or the weldment connector, I can move that over. I have to think about it, but then the dimension updates with it.
And the same thing is true outside of the ticket as well. When I go back to the model from which this ticket was derived, if I make changes here, those will go back to that. They'll go over to the framing plan. If I have all of my CAD dimensioning completed using our parametric dimensions, I can make it so that when I make a change here, not only do the model, the framing plan, the line work change, but they also automatically update all the dimensioning and the annotation I've done as well.
Right. So I think we also wanted to show that in this case, we were just adding reinforcement and modeling a simple straight girder with no camber, but we can also handle more complex situations. So if I hop over to another drawing file that I've set up, you can see kind of what I want to show you guys as a final product, but I'll show you how I got to that point here in just a second. So all I really need to do for this is another type of extrusion, a sweep along path extrusion. Extrude along path, yep.
And this is just to demonstrate, we know that some folks cast pre-cambered girders, but also just to demonstrate that these tools are not just suitable for things that are straight and flat and simple. They can be used to detail bar along complex curvature. They can be used to detail bar for objects that change along their length. This is applicable to a heck of a lot more than just girders. If you do things like vaults and culverts, if you do wall panels, these tools work for all of these.
Yeah, exactly. So same process as before, just creating another section down the length of the girder. Take a look at it here. And now I can just start adding my reinforcement in here again like I did before. Not being too exact with my placements.
Well, while you're working on that, I will ask, compared to the other, I know in your former life, you had tried to use other tools to do detailing in 3D like this. Compared to that, how's this stacking up?
Yeah, I've used platforms that weren't really made for doing reinforcement and basically just trying to get a program to do something that it's not really built for can cause a lot of heartache and Usually it causes some slowdown of performance in your models, but also doing it in a 2D method as well. And that just trying to keep a track of quantities and updates from one view to another view, it just takes a lot more effort than really what we need to nowadays.
Fair enough. All right. So yeah, let's wrap this up and show everyone how this last little bit of reinforcement is going to work.
All right. So I just have to select my path here.
And voila.
And voila.
So again, to recap, automation for creating these things that's in line with the CAD skills and long experience that a lot of folks in the industry have, but which culminates in a model that can be used to do a lot of things, manage a lot of information, and reduce errors across the entire process that happens after that, from ticketing to purchasing to casting to erection. And with that, I think we can open the floor for questions. So we will hand it back over to PCI's folks, unless Anders, anything else?
Nope, that's it for me.
All right. Well, thank you all. And back to PCI.
Thank you, David and Anders, for a great and informative presentation. We'll now start the Q&A portion of our presentation. The first question is, can you reuse projects?
Anders, I think that probably heads your direction.
Yeah, so you can definitely reuse projects. You can take an old project, make a copy of it, and then stretch your components within it and make the changes that you need to and call it a new project. Or what you can do is save precast components that you make, similar to the components that we made during the webinar. You could save those to your library and then recall those in a future project. And that would include the concrete for the girder, the reinforcement, any fixtures that you add to the girder, as well as the shop drawings.
Yeah, the concept of a template goes a lot further when we do it this way than it ever did or could in just plain CAD.
Okay, thank you. I have another question here. You show using loose reinforcement. Does Allplan handle mesh?
Yes, it does. There are some really good tools for just welded wire mesh as well as bar meshes and engineered bar mesh.
Yep, and you can set up your own custom configurations of mesh as well.
All right, thank you. A question just came in. It says, that asks, can you model camber?
Yes, you can model camber. We showed a little bit of that at the very end. It was a little bit more extreme than you'd probably see in a normal bridge girder, but yes, you can model camber.
Yeah, the initial model that Anders showed as well came out of bridge-specific modeling tools. Typically, we don't see precasters using those, but it is possible to lay out multiple versions of a full bridge model that have both cambered and uncambered states, or rather cambered and fully loaded states, even to do construction staging there. So there's quite a bit of capability that we didn't use today because it wasn't really core to what we wanted to cover.
All right. I have a second or fourth question here, sorry. What formats can Allplan provide for fabrication machinery?
So I think we alluded to this. We can export bar list and fabrication data into ASA and SULE, which are very commonly used to manage rebar fabrication. As well, we have direct to machine exports, some built around XML formatting. Under's the one that's escaping me. Do you remember what it's called?
BBBS.
Yep, that was it. In addition, beyond bar, there are a couple of other fabrication useful formats that we can do, including things in DXF to drive CNC machinery, as well as STV and STP for CNC or for 3D printing applications. So there's a lot that can feed directly into machinery without having to put a human in the loop to transpose a bunch of digits from one place to another.
All right, thank you so much. I have one more question here. How customizable are the bar schedules?
They are very customizable, but Allplan just by default out of the box comes with many variations, including a ACI standard schedule that you can use and modify as needed. David, did you want to add more to that?
Yeah, certainly we've built a lot of custom schedules for our customers. We've taught customers how to do it. That range is not just things that you would typically see in a shop or in a rebar fab shop, things that are kind of maybe based on CRSI or ACI. We also have built some of the standard bar schedule formats for state DOTs and infrastructure owners. So it's pretty darn versatile, let's just say.
All right, it looks like that's all the questions we have. We'll hold up for another 10 seconds to see if any other questions come in. If anyone has any, please go ahead. Speak now, forever hold your peace. Well, it looks like that's all the questions we have. On behalf of PCI, I'd like to thank both David and Anders for a great presentation. As a reminder, today's presentation will be recorded and uploaded to the PCI eLearning Center, and a pop-up survey will appear after this webinar ends. If you have any further questions about today's webinar, please email marketing@pci.org. Thank you again. Have a great day, and please stay safe.